So this is alternative to practical planning experiment file. Okay, this question is there. Whenever you're planning an experiment, you try to answer the points which are listed. You will try to answer each point separately. So in this one, a student investigates the motion of the ball through the air. Plan an experiment which will enable him to investigate how the range of the ball depends on the angle at which it is launched. So if we launch at different angles, range means the horizontal distance travel. So if we launch any sphere from a flexible channel, it will move. And if we change the launching angle, the distance it travel, the horizontal distance it travel, that is called a range. No, you will not lose a mark for the order. Any order you can answer this, but I advise a student to write the answer as they ask the question. Like try to answer those points which are listed rather than writing a full in your own words. The advantage if you do like this, that it will like you will cover all the points. So order, for example, if you're not following the order, you will not lose the marks. Yes, range is always a horizontal distance. That's right. Range is a term which is always used for the horizontal distance. So now what we have to do, we have to plan an experiment which enable him to investigate how the range of a ball depends on the angle at which it is launched. What is the meaning of the term range? Range means the horizontal distance which an object travel. Like example, if I if I kick a football, what is the horizontal distance covered by this football? That is called a range. So range is refers to the horizontal distance which is covered by an object. So we want to investigate, the question is, we want to investigate how the range depends on the angle of the launch. Like here we have a channel. So here we have a flexible channel, a variable angle is there. So we release a ball and we change this angle and we're investigating how this affects the range or a horizontal distance traveled by. No, this is one is the range of the answer. When I say range of answer, I'll say that this answer ranges from 4 to 6. Like that is a value, range of the value. But there's also a term range is used specifically for the horizontal distance. So the for horizontal distance, we also use the term range. So plan an experiment which enable him to investigate how the range of a ball depends on the angle at which it is launched. The range is the horizontal distance they mention here, traveled by after leaving the channel in figure 4.1. The apparatus available, a flexible channel is available to us, which can bend at different angles, and a selection of the balls are there, and each of different diameter and the mass. In your plan, you should list additional apparatus. What is an additional apparatus we need? Additional apparatus, because I want to determine the range. I want to determine the distance. So if I want to determine the distance, what I need a meter rule. That is one thing. And very good. Also need a protractor. Why? Because we want to investigate how the angle, the main experiment is the relation between the angle and the range. So how angle can be determined? Angle can be determined by using a protractor. And how range can be determined by using a meter rule. So what are the instruments? What are the additional apparatus I need? I need protractor. and I need a meter rule. Meter rule or a meter scale. Explain how would you do the experiment. You may add to a figure 4.1 if it helps your explanation. So how we'll do the experiment? We'll place a sphere, like we place a we'll place a ball at one point of the flexible channel and we release. So the ball will move and we measure the angle as well. Like we place a ball, like we first measure the angle of this flexible channel from the horizontal. Then we release a ball from a position, a fixed position from a flexible channel. And when the ball will move, it will travel some distance and land on the floor. And to measure the range, what we will do, we will determine this horizontal distance by using a meter rule or a meter scale. So using or 2 meter rules or 2 meter scale, we can determine this horizontal distance as well. So how it can be done? So we just set up like an angle and we roll the ball and we measure the range by using a meter rule. And then we repeat the experiment, but don't only say repeat the experiment. You should say how many times it should be done. So you say repeat the experiment 5 times or 3 times for different angle. 5 times is good. So repeat the experiment with 5 different angles. Is it clear, the procedure, how we carry out this experiment? Yes, I will repeat. If they say you may add to a figure, you should always add, or if it's same point. No, you should always add. The reason is that the reason why you should always add to a diagram, we want to determine this angle. The variable angle is this one, not the initial angle. We want this angle variation. So you should always add to a diagram. So how to carry out this experiment? We'll measure the initial angle or measure the angle by protractor. Then what we will do? We will release the ball. Then we'll measure the range by meter rule. Then we'll repeat with 5 different angles. So we'll change the angle 5 times. That is how it should be done. Yeah, measure the distance it traveled. That is the range. Now they ask us, you may add to a diagram. So what we can add to a diagram, if we want to measure, like, let's say this we place on the bench. So we place this on the bench and we can have this angle, the variation in the angle. Now, if you draw 1 meter rule, that's fine. If you draw 2 meter rule, that's also okay. This is a second meter rule for the range. And you have a protractor for the angle from the horizontal. The minimum steps or a bullet point you for each one like this point, you will write the answer separately. This point, you write the answer separately. State the key variables that you keep constant. What are the variables we should keep constant? What are the variables we should keep constant? The mass, the diameter of a ball, the mass of the ball, the material of the ball, the height, good, the length of the channel. Yeah, a lot of things are there. So, lot of things are there. It can be diameter of the ball, the mass of the ball, the height of the ball. Like height from which the channel from the ground. Yes, that's also correct. The height of the channel from the ground should also be same throughout. So mass, I can say mass of the ball, but don't only say mass. You should specify the diameter of the sphere or a ball, the height of the channel above the ground, the position on the channel where we release this ball. Like if one experiment I release from here, another one I release from here, definitely it will affect the range. So I should release them from the same point. So point at which we are release these. No, angle should be different because we are investigating how the change in the angle affect the range. So angle cannot be same. Angle should be different. These angle will be same. The angle with the vertical should be same, but this angle will be different. Not the mean position, means the position where we release. Like if I release from point A, the first sphere, I should release all of them from point A. But when you write the explanation, I told you whenever you're writing a procedure, you should include the precaution as well. So what should be the precaution here for this one? So you should avoid a parallax error in measurement. When you're recording, you should avoid a parallax error, look perpendicular. Don't push the ball. Like you should not push the ball, you should just release the ball. If you push the ball, because every time you'll push at a different force, that will affect the range. So you should not push the ball. You can also like mention, you can mention a precaution and the sources of error or uncertainty in the procedure itself. Then draw a table with a column heading. So what is a table? We have an angle. Angle is theta, and the like angle is represented by theta, and the unit is degrees. And the range is a distance. You can use the letter R or you can also use the letter D. No need to write the full sentences. You can write D. And what is the unit? Centimeter. Even though the SI unit of the length is meter, but as I mentioned in the lab, we use millimeters and centimeter rather than a meter. Then how would you use your result to reach a conclusion? So what we will do, we will plot a graph between the distance and the angle and compare the trend. Like we'll plot a graph between the range and the angle. So we can plot a graph between the angle. Angle is an independent quantity because we are changing. So that should be on x-axis and the dependent quantity on y. So what we'll do, we'll plot a graph between the angle and the range and compare them. Like if the change in the independent quantity or the change in angle produces any change in the range. Is it clear, this experiment? Is it clear, the whole experiment? Okay. Yeah, if they, you should mention the type of chart like bar, and I will read the points which score the marks. Look, this is a because for this file, after every question there's a answer is written. So as a reference, don't try to write as it is. Try to write in your own words. But these are the reference. So we use a meter rule and a protractor. We'll score 1 mark. We mentioned like initial angle we set up. We roll the ball and or release the ball and we measure the range. We score the second mark. We repeat with different angles. So not only say repeat, look, see, at least 5 sets of data are there. So when you say that repeat the experiment with 5 different angles, so you'll score 2 marks, not one. One is for different angle, one is for using the term 5. That's why I always advise that when you write, don't say only repeat the experiment, mention the number of the times you should repeat. Then the control variables, the diameter, the mass, the angle, or the height of the upper channel. Then the table with the column heading with the correct units, and then compare the readings in the table if see in independent variable produces any change in the dependent. Like just plot a graph between angle and the range and compare whether a change in angle produce a change in the range. That's a comparison you will mention. And these are the additional points, like from additional point, any one you write from additional point. So where it should be added, this additional point should be added in this part. When you're writing, no, you don't have to use the term independent or dependent. This is a generalized answer they give. But what you will use, like you will say, compare the if like compare the table in reading in the table, or plot a graph between the range and the angle, and compare if the change in angle produces a change in the range. Independent one is the one which we change, and dependent one, like example, angle is what we are changing. So angle is independent. And dependent is if I change the angle, the range it should travel, that will change. So range depends on the angle. So the one which we change, we call independent. And the one changes because of our change, we call dependent. Is it clear? Any question or doubt related to the class?